Good evening, everyone. I'm Sathwika from CSC department. In this video, I'm going to give a presentation on visualization of data using Matplotlib and Seaborn in Python. So, coming to data visualization in Python. So, why data visualization in Python? Why do we need to study data visualization in Python? Because it's a quick and easy way to convey the concepts in a universal manner. And what is data visualization? It is a graphical way of representing information and data. And what are the types of data visualization in Python? They are Matplotlib, Pandas visualization, Seaborn, ggplot, and Plotly. These are the plotting libraries you use for data visualization in Python. So next, coming to overview. So we are going to learn about visualization libraries and modules in this presentation, and version overview. Visualization plot types. They are bar chart, stacked area graph, scatter plot, horizontal bar chart, pie chart, box plot, stacked bar chart, histogram, violin plot, root bar chart, density plot, heat map, line chart, density plot with histogram, and time series. So coming to visualization libraries and modules, here if we consider Pandas library, it is an open source software library providing high performance, which is easy to use, and data structures and data analysis tools for the Python programming languages. And the import statement for this is import pandas as PD. Coming to NumPy library, NumPy is a fundamental package for scientific computing with Python, providing multi-dimensional array object, various derived objects such as masked arrays and matrices. The input statement for this is import NumPy as NP. The next one is Matplotlib. Matplotlib is a Python 2D plotting library, and the import statement for this import Matplotlib. And matplotlib.pyplot, it is a state-based interface to Matplotlib. It provides a MATLAB-like plotting. The import statement for this particular library is import matplotlib.pyplot as PLT. And Seaborn, it is a Python data visualization library based on Matplotlib. So the import statement for this goes as import Seaborn as SNS. And the next one is Plotly. Plotly Python open source graphic library makes interactive graphics online. So it is used to make interactive graphs online. And the import statement for this is import plotly.express as px and import plotly.graph underscore objects as go. And coming to Bokeh, it is a Python-based interactive visualization library that targets two web browsers. And coming to the import statement for this is from bokeh.plotting import figure and show. Here, Bokeh is used to present a very large and streaming data sets. Now, coming to the version overview, the 2015.0.09 version, it is a basic visualization plots using Matplotlib, Seaborn, and Pandas. And 2017.06 version, it is visualization plots using Seaborn, update some graphs and charts with new functions and data. 2018.03 version, it is a data visualization with Plotly and 3D visualization plots, update some graphs and charts with new functions and data. 2018.12 version, it's a network graph visualization with Bokeh, and it has some interactive data visualization with Bokeh, geo data mapping with Bokeh. Now coming to visualization plots using Matplotlib, Seaborn, and Pandas. So first of all, coming to bar chart. What is a bar chart? It shows comparisons between different categories, different parts of a whole. It shows the relationship between a numerical variable and a discrete variable. Now, variations of bar chart, they are vertical bar chart or column chart. The best used to visualize relationship or comparisons with chronological data. And the horizontal bar chart, it is useful when category labels are long. The stacked bar chart, it is used to compare two different parts of a whole using discrete or continuous variables. And the grouped bar chart, it is used to compare multiple data series in a given category. So coming to vertical bar chart or column chart. So these are the functions for plotting a bar chart. That is figure AX is equal to PLT dot subplots. Number of rows is equal to number of underscore of underscore row, and number of columns equal to number underscore of underscore col. And figure says it has to take X and Y. This creates an figure and a set of subplots and sets figure size. It returns a single axis object or an array of axis objects if more than one subplot are created. And matplotlib.pyplot.bar of x height width bottom equals none, align center and data none. These are the keyword arguments. They are used to make a bar chart, and the parameters x, height, width, bottom and align. And the keyword arguments are color and alpha. Here x, it indicates a sequence of scalars. The bars are positioned at x with a given alignment. And height and width indicates the scalar or sequence of scalar or array like. The dimensions of bar are set by these parameters, and the bottom indicates scalar or array like. The vertical baseline is bottom or the default value is 0, and the align indicates the alignment of the bars to the x coordinates, center and edge. Default is center. And the keyword arguments color, it indicates scalar or array like, the color of the bar faces. For example, we have set blue color as color B in the given example, and alpha is nothing but float or none. It is used to set the alpha transparency of the patch, a 2D artist with a face color on an edge color. Now for an example, we have set alpha is equal to 0.6 in the given example. And matplotlib.pyplot.xtix, where tix equals none and labels equals none, keyword argument. It is used to get or set the current tick locations and labels of the x-axis. Now coming to vertical bar chart example. So this is an example for vertical bar chart. And so now the matplotlib.ticker.func formatter or function, which it is used a user-defined function, and it is basically implemented for label formatting, and it takes two inputs, a tick value x and a positional value pos, and it returns a string containing the corresponding tick label. An example, now it displays a market cap of different technology industries, and this is the data information. First, we have to prepare the data. Then we have to plot the bar chart. Then coming to horizontal bar chart. Functions for plotting horizontal bar chart. These are the same functions that as compared to the previous vertical column chart. They are matplotlib.axis of BARH, and they are self, y, width, height is equal to 0.8, left is equal to none, align, center, and the keyword arguments. These are variable length keyword arguments, and the parameters are y, width, height, left, align, and the keyword arguments are color and alpha, where y indicates a scalar or array-like structure, and it has got y coordinates of the bars. And the width indicates scalar or array-like structure. It has got sequence of scalars. The dimensions of bar are set by these parameters. With our height, they both have got the same sequence of scalars. And the left indicates the sequence of scalar structure, the x coordinates of the left sides of the bars, and the default value is set to 0. The align indicates the alignment of the bars, the y coordinates where center, edge, and the default center. The color indicates the scalar or array-like structure, which further indicates the color of the bar faces. And alpha indicates float or none value. We have set the alpha transparency of the patch, a 2D artist with a face color or an edge color. Now matplotlib.picker.func formatter of function. It uses user-defined function for label formatting. And eggs.set underscore whitex self ticks minor equals false. It sets the whitex with the list of ticks. If the parameter is minor, then it's false. And it sets major ticks. If it's true, then it sets the minor. If the parameter is if the parameter minus is false, it says the major ticks. Major ticks. If it is true, it sets the minor ticks, and the default value is false. And eggs.set underscore white tick labels self labels font dictionary equals none and the minor equals false is a variable length keyword arguments. It sets the white tick labels with a list of strings, and with a list of strings labels. And eggs.invert underscore y-axis self, it is used to invert the y-axis. Example, now we have displayed a market cap of different technology industries this way. First, we have to prepare the data, then we have to plot horizontal bar graph, bar chart, and have done this. Now, moving to stacked bar chart, functions for plotting a stacked bar chart. They are matplotlib.pyplot.bar of x height, width, and bottom is none. Aligned to center and data is none. The variable length arguments. Now the parameters here are x height, width, bottom, and align. X takes a sequence of scalars and the bars are positioned at X with a given alignment, where height and width are nothing but scalar or sequence of scalar or array-like structures, and the dimensions of bar are set by these parameters. The bottom is scalar or array-like, and the vertical baseline is bottom, and where the default value is 0. Now in the given example, we have set bottom equals revenue to plot stacked bar chart, and the alignment of the bars to the x coordinates towards the center and edge where the default value is center. Now the matplotlib.pyplot.xticks where ticks equals none and labels are none, and it takes variable length keyword arguments. Now we have to get or set the current tick locations and labels of the x-axis. And ax.y-axis.set major formatter, it provides configurable tick locating and formatting. And matplotlib.picker.function formatter, it uses a user-defined function for label formatting. Now this is an example of stacked bar chart where it is a comparison between Microsoft's revenue and earnings in billions for the year of 2010 to 2015. Now data, it was collected on this basis. A plot is generated for a stacked bar chart for revenue versus earnings, and it takes two arguments, and this is the data involved in that. Now coming to group bar chart. Functions for plotting group bar chart are matplotlib.pyplot.bar of x height, width, bottom none, aligned towards center, data is none, and variable length keyword arguments. It is used to make a stacked bar chart. The parameters are x height and width, bottom, and align. X, it takes a sequence of scalars and the bars are positioned at X with a given alignment. In the given example for bar 1, we have set X equals to X minus width by 2. And for bar 2, we have set X equal to X plus width by 2. To plot a group bar chart, and the height, width, it takes scalar or sequence of scalar or array-like structures, and the dimensions of bar are set by these parameters. The bottom is a scalar or array-like structure, and the vertical baseline is bottom where the default value is set to 0. Now align the alignment of the bars to the x coordinates towards the center and edge, and the default value is towards the center. Now coming to the second function, matplotlib.pyplot.xticks, where ticks equals none and the labels are none. It takes a variable length keyword argument. Now it is used to get or set the current tick locations and label of the x-axis. And axis.y-axis.set underscore major underscore formatter, it provides configurable tick locating and formatting. Now matplotlib.ticker.function of formatter, It uses a user-defined function for label formatting. And the auto label of bars, it attaches a text label above each bar, displaying its height. Now this is an example for group bar chart, where the comparison between Microsoft's revenue and earnings in billions for the year 2010 to 2015 is done, and have plotted a group bar chart between revenue and earnings. The two arguments are the value and the tick position. Now coming to a line graph, line chart, it displays time series relationship with continuous data. And these are the functions for plotting line graph. They are axis.plot of self and variable and positional arguments. Scale x is true, scale is true, and data is none. And it also takes variable and keyword argument. We have to plot y versus x as a line and or markers. And we have to call it signatures plot of x and y format. And then we have to call variable and positional arguments where data is none, and variable and keyword arguments. Now we have taken this parameter x and y format data and variable and keyword arguments, where x and y are array-like or scalar structure, and the coordinates of the points or line nodes are given by x and y. Format is a string optional and a format string, example RO for red circles. And the data is an indexable object. It is an optional and object with the label data. Now variable and keyword arguments are used to specify properties like line label for auto legend, line width, and initializing marker face color. Axis.tick underscore parameters of x axis is taken as x, and the direction is out, where length is 3 and width is 0.5. Here the label rotation is 75. It is used to decorate the appearance of ticks, tick labels, and grid lines. Axis.grid of color light gray and line style of this line, and the line width is 0.5. It is used to provide configurable grids. Now this is an example for line graph. Here line graph of residential electricity usage of San Diego from 1990 to 2014 is collected. The source is from California Electricity Consumption Database, and this data was collected from data.ca.gov. So this is a plot line graph of San Diego residential electrical usage, and this is the line graph for this. Now coming to stacked area graph. Stacked area graph, it displays the contribution of each data series to a cumulative total over time. Now the functions for plotting stacked area graph are axis.stack plot of axis, x arguments and the labels, where colors are none and the baseline is set to 0. Data is takes none, and variable length keyword arguments are taken. Now we have to draw a stacked area plot. The parameters are taken as x and y, where x represents one-dimensional array of dimension n, and two-dimensional array, y represents a two-dimensional array of dimensions m and n, or sequence of one-dimensional arrays, each dimension 1 into n. Now the baseline, it is used to calculate the baseline, 0 system, SYM, this wiggle, weighted underscore wiggle. And the labels are used to take length as n sequence of strings, and labels are used to assign to each data series, and the colors, length and sequence of colors, a list or tuple of colors used to color the stacked areas. Axis.tick of underscore parameters, where axis is taken as x, and the direction is out, length is 3 and the width is 0.5. Here the label rotation is 75. It is used to decorate the appearance of ticks, tick labels, and grid lines. This is an example for stacked area graph of residential electrical usage of California country. And this is the plot stacked area graph, as we can see on the screen. Now coming to pie chart. Pie chart is a circular statistical graphic which is divided into slices in order to show part to whole relationship with continuous or discrete data. It is best used with a small data. Functions for plotting pie chart are axis.pie, self x, autopack none, and text props none, and it takes variable length arguments. Now we have to make a pie chart of array x. So the parameters are x array like the wedge sizes. Auto PCT, it's none, default string or function, and it is optional. If not none, it is a string or function. which is used to label the wedges with the numerical value. And text props, it is a dictionary and it's optional, and the default value is none. Dict of arguments to pass to the text objects. Other parameters are explode, labels, colors, PCT distance, shadow, label distance, radius, counterclock, wedge prop, etc. Now coming to plt.set set ps for the object, it takes objects and variable length arguments, and like it takes variable length positional arguments, and also it takes variable length keyword arguments. It is used to set the property on an artist object. Now coming to the example of pie chart. Pie chart of total residential electricity usage of California countries from 1990 to 2015 is displayed in this format. So as you can see onto the output screen. Now, moving on to histogram. Histogram, it displays the underlying frequency distribution of a set of continuous data, that is univariate data. The functions for plotting histogram are axis.hist of self x bins equals none, the range is none, and the density is also none, where hist type is equal to bar. It takes variable length arguments and variable length keyword arguments. Now, the parameter it takes is x bins and density, where x represents an array of sequence of n arrays, and it takes input values. This takes either a single array or a sequence of arrays which are not required to be of same length. Bins, it is an integer or sequence of string where it is an optional. If an integer is given, bins plus 1 bin edges are calculated and returned. If bins is a sequence, it gives bin edges including left edge of first bin and the right edge of the last bin. Now density, it is a Boolean value and it's optional. If it is true, the area under histogram will sum to 1. And other parameters are weights, cumulative, bottom hist type, align, orientation, argvid, log, label, stack, node, data, and the variable length keyword arguments, etc. That's an example of an histogram of NBA players' weight, and we have to load NBA data from file into pandas data frame in this regard. So this is a histogram. Now the density plot, it is used to display the univariate distribution of data. It uses a kernel density estimate to show the probability density function, PDF of the variable. Functions for plotting density plot are seaborn.kdplot of data2 is none and the shade is false, and here the vertical is false and the kernel is GAU. Fit and plot a univariate or bivariate kernel density estimate. Now the parameters are data 1D array like, it is used to input the data. Data2 is 1D array like and it is optional. Second input data, if present, a bivariate KDE will be estimated. Now the shade, it is Boolean value and it's optional. If true, the shade in the area under the KDE curve, and vertical, it is Boolean and it is optional. If it is true, then density is on the x-axis. And the kernel, it's JU, cos, PIW, EPA, tri and tri-W. These are all optional. And code for shape of kernel to fit with, these are bivariate with KDE and can only use Gaussian kernel. And this is an example for density plot. For the density plot of NBA players' weight using Seaborn KDE plot function. So we have set SNS.set of style is white, palette is deep, and color codes is true. This is used to load NBA data from file into pandas data frame. Now this is a density plot with histogram. An example of NBA players' weight using Seaborn displot function. And this is the same weight distribution of NBA players, where weight is taken on x-axis and frequency is considered on y-axis. Now coming to scatter plot. Scatter plot, it shows the correlation between two sets of data, that is bivariate data. And the scatter plots are best used for large data set. And the functions for plotting scatter plot is dataframe.plot.scatter self x, y, s is none and c is also none, is variable and keyword arguments. Now we have to create a scatter plot with varying markup point size and color. It returns matplotlib.axis, axis or numpy.nd array of them. Now it takes the parameters x, y, s and c and the variable length keyword arguments. X is nothing but it is an integer or string value, and the column name or column position to be used as a horizontal coordinates for each point. Y is integer or string value, the column name or column position to be used as a vertical coordinates of each point. And S is a scalar or array like, it is optional, and the size of each point. C is a scalar or array like, and it is also optional. It is used to indicate the color of each point. The variable and keyword arguments are the keyword arguments to pass on to the data frame dot plot. Now coming to an example of scatter plot using iris dataset. So in this given example, the scatter plot shows petal and sepal distribution for each species, and this data was collected in this regard. So for each species, we have to check whether it is petal or sepal distribution. So we have compared to sepal comparison and petal comparison. Now coming to box plot, it displays the distribution of data through their quartiles. That is, minimum is first quartile and median third quartile and the maximum. It displays outliers with their values. Functions for plotting box plot. The first one is axis.boxplot of self x where notch is equal to none. Patch underscore artist is none and the labels are none. Flyer props are none. We have to make a box and whisker plot for each column of x or each vector in sequence x, and it returns matplotlib.axis or numpy.nd array of them, and the parameters are x, notch, labels, patch underscore artist, and flyer pops, where x is an array or a sequence of vectors, the input data, and notch is a boolean type and it is optional, it returns false. If true, it will produce a notched box plot, otherwise a rectangular box plot is produced. And the labels are of sequence, these are optional, they are the labels for each data set. The length must be compatible with the dimensions of x. Patch underscore artist, it's a boolean value, and the option value, it's false. If it is true, then it produces boxes with the line to the artist. Otherwise, boxes are drawn with the patch artist. The flyer props, they are of dictionary values and they are optional. They're used to specify the style of the flyers. Now this is an example for box plot. Here we have a plotted box plot using tips data. So in this example, the box plot shows tips and the data was collected in this regard. So the tips of female and male are shown here. Now coming to the Boolean plot, it plots the numeric data with a rotated kernel density plot on each side. It shows the probability density of the data at different values, usually smoothed by a kernel density estimator. The functions for plotting the Boolean plot are Seaborn dot Boolean plot of x is none and the y is also none. HUE is none and the data is also none. Their order is none and HUE underscore order is also none. Now it draws a combination of box plot and kernel density estimate. The parameters are x, y, HUE and data order HUE underscore order. So XY takes the names of variables in data or vector data. These are optional. And the data, it is in the format of data frame, array or list of arrays. These are optional. And the data set is used for plotting. If X and Y are absent, then this is interpreted as wide form. Otherwise, it is expected to be a long form. Order or HU underscore order, it returns a list of strings. These are optional. And order to plot the categorical levels in, otherwise the levels are inferred from your data objects. Now this is an example for Boolean plot. Boolean plot using the iris data set. So in the given example, the Boolean plot shows sepal length comparison for each species. Data was collected from UCI machine learning repository, and this is, we have to load the data first, and we have to draw a Boolean plot to show the sepal length comparison. So this is the Boolean plot for sepal length comparison. Now coming to heat map. Heat map, it represents data where individual values contained in a matrix are represented as colors. And functions for plotting heat map are heat map of data, row underscore labels, column underscore labels, and the axis is none, where C bar is equal to keyword argument, and the C bar label is, it takes a variable length keyword arguments. And we have to create a heat map from a NumPy array and two lists of labels. The parameters are data, row underscore labels, and column underscore labels. AX is represented as axis, and C bar underscore KW and C bar label. Now coming to data. Data is a 2D NumPy array of shape n and m. Row underscore labels, it returns a list of array of length n with the labels for the rows. Col underscore labels, it is a list or array of length m with the labels for the columns. And ax, it is a matplotlib.axis. It is an instance to which the heat map is plotted, and this is optional. Cbar underscore kw, it is a dictionary with arguments to matplotlib.figure of color bar, and it is optional. C bar label, the label for the color bar, and this is also optional. So this is an example for heat map. It shows heat map of infectious disease by California country, and the data was collected from the GitHub heat map, and this is an infectious disease by country California 2014. So first we have to plot the data, and then have to input this all the text format. We'd get this plot, we'd get this heat map plot. Now coming to time series, a time series, it displays a series of data points indexed in time order, and it is used to draw time series using Apple stock price data. I mean, it draws time series using Apple stock price data. Now this data, it was collected from GitHub time series. First of all, we have to generate the plot, and the two arguments are the values and the tick positions over here, and it displays the Apple stock price in the format of time series. Now coming to the summary part. We have witnessed the plot types, that is bar chart, stacked bar chart, group bar chart, and API call is matplotlib.pyplot, bar of x height with bottom none, align center and data none. Oh, whereas for horizontal bar chart, it is matplotlib.axis.barh self y with height is 0.8, left is none and the align towards center. For the line chart, it's matplotlib.axis.plot of self, and it takes a variable length positional arguments where scale x is true and scale y is also true. Data is none, and it also takes variable length keyword arguments. Coming to stacked area graph, matplotlib.axis.stackplot, and it takes axis x as argument, and it also takes variable length arguments where labels and colors are none. The baseline is 0. Pie chart, matplotlib.axis.pie, where it takes self and x as an argument. Auto PCT none, and text props is also none, and it takes variable length arguments. Histogram, the API call is matplotlib.axis.hist. It takes self as argument, and it also takes x. Bins are none. Range is also none. Density is none, and the hist type is bar. The density plot, API call is seaborn.kdipplot, and the data2 is none. Shade is false. Vertical is false, and the kernel is GAU. Now histogram with KDE plot, the API call is seaborn.diskplot. Bins are none. It takes A as an argument. Hist is true. KD is true and RUG is false. Hist underscore KWS is none. And the scatter plot, API call is dataframe.plot.scatter. It takes self, XY as an arguments, where S is none, C is none, and it takes variable length keyword arguments. Box plot, the API call is matplotlib.axis.boxplot, where it takes self, X as arguments, where notch is none, and patch underscore artist is also none. Here labels are none. And coming to the violin plot, the API call is seaborn.violin.plot, and it takes x, y as an arguments. Both are none. HU is none, and the data is also none. And order is none. HU underscore order is also none. Coming to heat map, its API call is heat map of data row labels, column underscore labels, and AX is none. C bar underscore KW and the C bar label, and it also takes variable length keyword arguments. Now coming to the Matplotlib. Introduction to Matplotlib. It is an amazing visualization library in Python for 2D plots of arrays. So what is a Matplotlib? It is a plotting library for Python, and it is numerical mathematical extension of NumPy. It is a 2D and 3D plotting Python library, and it was introduced by John Hunter in the year of 2002. These are Matplotlib graphs, scatter plot, step plot, bar chart, fill between, time series, box plot, and histogram. So it is a low-level graph plotting library in Python that serves as a visualization utility. So Matplotlib is a multi-platform data visualization library built on NumPy arrays and designed to work with broader SciPy stack. It was introduced by John Hunter in the year of 2002, and one of the greatest benefits of visualization is that it allows us visual access to huge amounts of data in easily digestible visuals. Matplotlib consists of several plots like line, bar, scatter, histogram, etc. It's an amazing visualization library in Python for 2D plots of arrays. Now, this is Matplotlib is created by John D. Hunter. It was developed in 2002 and was released in 2003. Now, how to install Matplotlib? We have to open command prompt in Windows, then have to set user account and have to run the following command. When computer is connected to the internet, the command is pip install Matplotlib, and we have to import Matplotlib as empty. In order to check the version of Matplotlib, we have to import Matplotlib as empty and we have to print empty underscore version. It would display the output, the corresponding version. And most of the Matplotlib utilities lies under the Matplotlib submodule, under the pyplot submodule, and are usually imported under the plt alias. Import matplotlib.pyplot as plt. Now we can import Matplotlib in two ways. Either we can import matplotlib.pyplot as plt, or from Matplotlib we have to import pyplot as plt. Now coming to basic plots in Matplotlib. Matplotlib comes with a wide variety of plots. These plots helps us to understand trends, patterns, and to make correlations. They are typically instruments for reasoning about quantitative information. Now plotting x and y points. The plot function is used to draw points or markers in a diagram. By default, the plot function draws a line from point to point, and the function takes parameters for specifying points in the diagram. The parameter 1 is an array containing the points on the x-axis, that is horizontal axis, and the parameter 2 is an array containing the points on the y-axis, that is a vertical axis. Now this is a line plot. We have to import Matplotlib module. From Matplotlib, import pyplot as plt, and these are the we have to declare x and y values, and we have to declare a function to plot and the function to show the plot. Let's try to implement this program. So let's try to open the Anacron Navigator. So now let's import line plot. From Matplotlib, import pyplot as plt, and x value is 52947. The y values are 10, 5, 8, 4, and 2. plt.plot x and y and plt show. So we have got this line plot. And let's consider another example. So let's consider this example as well. We are drawing a line in a diagram from position 0 to 0 to position 6 to 250. Now let's try to import matplotlib as matplotlib.pyplot as plt, and we have to import numpy as np, where x is equal to np dot array of 0 and 6, and y is equal to np dot array of 0 and 250. Then plt dot plot of x and y, plt dot show, and we shall run the program. So we have obtained a line plot. Now let's consider another example, and we shall import matplotlib dot pyplot as plt and import numpy as np, where x is equal to np dot array of 0 and 6, x is equal to 1, 2, 3, 4, and 5. Then y is equal to 6, 7, 8, 9, and 10. Then plt dot plot of x and y. Then later we have to show this plot. So let's run this program. So we have obtained this graph. And now let's try plotting without a line. For this, we have to import matplotlib dot pyplot as plt, and we have to import numpy as np, where x is equal to np.array of 0 and 6. Y is equal to np.array of 0 and 250. Now we have to plot plt.plot of x, y, plt.show. Let's run the cell. So now we have plotted without a line graph. So we have obtained two dots at top, one at the top right end and the one it is at the bottom left end. And now let's import multiple points. That is from import matplotlib dot pyplot as plt. Before that, once let's go to the presentation slide. So here in plotting without line, in order to plot only the markers, we can use the shortcut string notation that is parameter O, which means strings. So we have done this. So let's go with this multiple points program. Have to import matplotlib.pyplot as plt. And then later, we shall import numpy as np. And then x is equal to np.array of 1, 2, 6, and 8. Now y is equal to np.array of 3, 8, 1, and 10. Now it's plt.plot of x and y, and then plt.show. So let's try to run this cell. So we'll be obtaining a plot with multiple points. And let's try to implement other program of default x-axis. For this, we have to import matplotlib.pyplot as plt. And we have to import numpy as np, where y is equal to np.array of 3, 8, 1, 3, 8, 1, 10, 5, and 7. And plt.plot of y, then plt.show. So now we shall run this program. So we have obtained default x-axis. Now what does this mean is that here, if we do not specify the points in the x-axis, then they will get the default values 0, 1, 2, and 3, etc. depending on the length of the y points. Now matplotlib markers, we can use the keyword argument marker to emphasize each point with a specified marker. So let's try to implement this program as well. Here we have to import Matplotlib dot pyplot as plt, and we have to import numpy as np, where y is equal to np dot array of 3, 8, 1, and 10, and plt dot plot of y and marker is of o. Now we have to show the plot using plt dot show. Let's try to run this cell. Okay, now this plot has been displayed. Now let's head back to the presentation slide. So the markers reference are marker O represents a circle and marker asterisk it represents a star, and marker dot represents point, and marker X is capital X. Marker capital X is X filled. It addition operator represents plus, and P is nothing but plus filled. S is square. Capital D represents diamond. Small d represents diamond thin. Small p represents pentagon. Capital H represents hexagon, and capital H also represents hexagon. Small v represents triangle down, and raised to the power represents triangle up, less than represents triangle left, and greater than represents triangle right. So now format strings FMT. This parameter is also called FMT and is written with the syntax marker, line, and color. So let's try to implement this program now. We have to import matplotlib dot plt, the pyplot as plt, o and r. So yeah, I've got this. And heading back to the presentation slide. So the line reference, the syntax for line, it is a description of a solid line, and the colon, it indicates dotted line, and this indicates dashed line, and this indicates dashed or dotted line. And the color reference, R indicates red, where G stands for green, B stands for blue, C stands for cyan, M stands for magenta, Y stands for yellow, K stands for black, and W stands for white. Now marker size, we can use the keyword argument marker size or the shorter version ms to set the size of the markers. Let's try to implement this program. Here we have to import matplotlib dot pyplot as plt, and then we have to import numpy as np, where y takes np dot array of 3, 8, 1, and 10, Now pt dot plot of y marker is O, ms is 20. Now plt dot show. Let's try to run this cell. So yeah, we got this. And now let's head back to the presentation slide. Now markers edge size. We can use the keyword argument marker edge color or the shorter MEC to set the color of the edge of the markers. Let's try to implement this program. For this, we have to import Matplotlib as PLT and import numpy as np. Then y is equal to np dot array of 3, 8, 1, and 10. Plt dot plot of y, and this is a marker which is O, where ms is 20 and mac is R. Now we have to plt dot show. Let's run. Let's run the slide. Okay, so we have got this. So let's head back to the presentation slide. Now marker face size, you can use the keyword argument marker face color as a shorter MFC to set the color of the edge of the markers. Let's try to implement this program as well. Here we have to import matplotlib dot pyplot as plt. We have to import numpy as np, and later y is equal to np dot array of 3, 8, 1, and 10. Plt dot plot of y marker is O, where ms is 20 and mfc is R. Plot dot show to run this cell. So we got this plot, and Let's head back to the slide. So the next one is line style argument. The line style argument. So we can use the keyword argument line style or shorter is to change the style of the plotted line. So let's try to implement this program as well. We have to import Matplotlib dot pyplot as plt, and we have to import numpy as np. Then later y is equal to np.array of 3, 8, 1 and 10. plt.plot of y, that is line style, is equal to dotted plt.show. So we have obtained the plot in line style format. And let's head back to the slide. So the line reference, this represents a solid line. This is a dotted and this is a dashed line, and it is a dash dot. Now the line color argument, or we can use the keyword argument color or the shorter C to set the color of the line. So let's try to implement this program as well. For this, we have to import matplotlib.pyplot as plt, and we have to import numpy as np. Then later y is equal to np.array of 3, 8, 1 and 10. plt.plot of y and color equals red. Now plt.show. Let's try to run this cell. So we have obtained the plot in red color. So let's try to do the presentation and slideshow. So the line width argument, we can use the keyword argument line width or the shorter LW to change the width of the line. Let's try to implement this program as well. Here we have to import matplotlib.pyplot as plt and import numpy as np, where y is equal to np.array of 3, 8, 1 and 10. plt.plot of y line width is equal to 20.6. plt.show. So let's run this cell. So yeah, we have obtained line width. we have obtained this line width graph. Now let's head back to the slide. Now multiple width argument. We can use the keyword argument line width or the shorter LW to change the width of the line. And let's head back to the slide, to the Jupyter notebook. Now here we have to import Matplotlib pyplot as PLT, and we have to also import numpy as np, where x1 is equal to np.array of 0, 1, 2, and 3, and y1 is equal to np.array of 3, 8, 1, and 10, and x2 is equal to np.array of 0, 1, 2, and 3, where y2 is equal to np.array of 6, 2, 7, and 11. Now plt.plot x1, y1, x2, and y2. plt.show. Let's run this cell. So we got a plotted graph. Now let's head back to the presentation slide. Now let's try to create the labels. So with pyplot, we can use the label, x label, and y label functions to set a label from the x and y axis. And now let's try to implement this program. Now we have to import matplotlib dot pyplot as plt, and we shall import numpy as np, where x is np.array, and it takes values 0, 1, 2, 3, 4, and 5. Y is equal to np.array of 0, 8, 12, 20, 26, and 38. plt.plot x and y. plt.xlabel os, and plt.ylabel nuns. plt.show. So this is a graph which is plotted over os and runs. Let's head back to the slide. Now to create title with pyplot, we can use the title function to set a title for the plot. So let's try to implement this program now. So import matplotlib dot pyplot as plt and import numpy as np. Then x is equal to np dot array of 0, 1, 2, 3, 4, and 5, and y is equal to np dot array of 0, 8, 12, 20, 26, and 38. plt dot plot of x and y. plt dot x label of overs. And plt dot y label of runs. Then plt dot title, that is sports data. Then plt dot show. Let's try to run this cell. So we have got this. Let's head back to the slide. Now we have to set font properties for title and labels. And now we can use the font dict parameter in X label and Y label and title to set font properties for the title and labels. So let's head back to the Jupyter notebook. Now we have to import Matplotlib dot pyplot as plt. Later we have to import numpy as np, where x is equal to np dot array of 0, 1, 2, 3, 4, and 5. And y is equal to np dot array of 0, 8, 12, 20, 26, and 38. Font 1 is equal to family serif and color blue. Then size, it's 20. And font 2, this is again family serif again, and the color is dark red. The size is 15. I have to plot x and y. Now the x label overs font dict is equal to font2, and we have to plot the y label as runs. Font dict is equal to font2. Next, title. Quotes data. Font dict is equal to font1. And plt dot show from this cell. So we got this sports data. Let's head back to the slide. Now, position the title. So we can use the LOC look parameter in title to position the title. So the legal values are left, right, and center, and the default value is center. So let's try to implement this program in the notebook. Here we have to import Matplotlib dot pyplot as PLT, and we have to import numpy as np, where x is equals to np dot array of 0, 1, 2, 3, 4, and 5, and y is np dot array of 0, 8, 12, 20, 26, and 38. I have to plot plt dot plot of x and y, then plt dot x label of overs, then plt dot y label as runs, then plt dot title as sports data. The location is aligned towards left, and plt dot show. So I've obtained this plot. So now let's head back to the slide. Now we have to add grid lines to a plot. So with pyplot, we can use the grid function to add grid lines to the plot. So we can do this. First, we have to import matplotlib dot pyplot as plt, and later we have to import numpy as np, where x is equal to np dot array of 0, 1, 2, 3, 4, and 5, and y is equal to np dot array of 0, 8, 12, 20, 26 and 38. PLT dot plot of x and y. Then PLT dot x label of overs. PLT dot y label of runs. PLT dot title of sports data that's present over the location of left, and PLT dot grid, then PLT dot show. So this is, we have obtained the plot in the format of grids. So now let's head back to the slide. So how to display the multiple plots? With the subplot function, we can draw multiple plots in one figure. And the subplot function takes 3 arguments that describes the layout of the figure. The layout is organized in rows and columns, which are represented by the first and second argument. And the third argument represents the index of the current plot. So let's try to input these steps. So first we have to import Matplotlib dot pyplot as PLT, and we have to import numpy as np, and the declaration for plot 1 where x is np dot array of 0, 1, 2, and 3. Y is equal to np dot array of 3, 8, 1, and 10. PLT dot subplot of 1, 2, and 1. Then PLT dot plot of x and y. Now for plot 2, x equal to np dot array of 0, 1, 2, and 3. Y is equal to np dot array of 10, 20, 30, and 40. And now we have to import plt dot subplot of 1, 2, and 3. Then plt dot plot of x and y. The next step is plt dot show. So let's try to run this cell. We have got this plot, multiple plots. And now let's try to implement other multiple plot. For this, we have to import matplotlib dot pyplot as plt and import numpy as np. The declaration for plot 1, here x is equal to np.array of 0, 1, 2, and 3, where y is equal to np.array of 3, 8, 1, and 10. Now plt dot subplot of 2, 1, and 1, plt dot plot of x and y. Now the declaration for plot 2, here x is equal to np.array of 0, 1, 2, and 3, y is equal to np.array of 10, 20, 30, and 40, plt dot subplot of 2, 1, and 2, and plt dot plot of x and y, plt dot show. Let's try to run this selected cell. So we got the subplots. So let's try to display the program of a super title now. For this, we have to import matplotlib.pyplot as plt, and we have to import numpy as np. Declaration for plot 1, x is equal to np.array of 0, 1, 2, and 3, y is equal to np.array of 3, 8, 1, and 10, then plt dot subplot of 2, 1, and 1, plt dot plot of x and y, and for plot 2, x is equal to np.array of 0, 1, 2, and 3, y is equal to np.array of 10, 20, 30, and 40, and plt dot subplot of 2, 2, and 1. Now plt dot plot of x and y, plt dot super title, that is my data. Now plt dot show. Let's try to run this program now. So my data is displayed onto the output screen with the super title. Now let's head back to the presentation slide. We have displayed the super title. So here we can add a title to the entire figure with a super SUP title function. Let's head back to the presentation slide. I've implemented this, and next, creating scatter plots. So with pyplot, we can use the scatter function to draw a scatter plot. And the scatter function plots one dot for each observation, and it needs two arrays of the same length, one for the values of the x-axis and the other one for the values of the y-axis. So scatter plots, they offer a convenient way to visualize how two numerical values are related in your data. It helps in understanding relationships between multiple variables, and using dot scatter method, we can create a scatter plot. So let's consider this example. So from Matplotlib module, dot pyplot import pyplot as plt. Then here x is equal to 5, 2, 9, 4, and 7, and y is equal to 10, 5, 8, 4, and 2. Plt dot scatter function of x and y. Then plt dot show. Let's try to run this cell. So yeah, we have got this, and let's try to implement another example program. So let's try to implement this example program as well. We have to import matplotlib dot pyplot as plt and import numpy as np, where x is equal to np dot array of 0, 1, 2, 3, 4, and 5, and y is equal to np dot array of 0, 8, 12, 20, 26, and 38. Plt dot scatter of x and y. Plt dot show. Let's try to run this cell. So yeah, we've got this output. And let's try to implement another program for scatter plot. Figure of X is equal to plt dot subplots. For that, to write import matplotlib from pyplot as plt, and next we have to import numpy as np. Here x is equal to np dot linspace of -1, 1, and 50, where y is equal to np dot random dot rand n of 50, x dot scatter of x and y. Now let's try to run this cell. So yeah, I've got this scatter plot. So now let's try to head back to the file presentation, and okay, so we have displayed this program. So now we have to compare the plots. Let's do this. Now here we have to import matplotlib dot pyplot as plt, and now we have to import numpy as np, and x is equal to np dot array of 0, 1, 2, 3, 4, and 5, and y is equal to np dot array of 0, 2, 8, 1, 14, and 7. Now plt dot scatter of x and y with color being red, where x is equal to np dot array of 12, 6, 8, 11, 8, and 3. And now y is equal to np dot array of 5, 6, 3, 7, 17, and 19. Now plt dot scatter of xy color is equal to green. Plt dot show from the selected cell. Now we have got this. Let's head back to the slide. Now to color each dots, shall implement this program now. For this, we have to import Matplotlib dot pyplot as plt, and later we have to import numpy as np, where x is equal to np dot array, that is 0, 1, 2, 3, 4, and 5, and y is equal to np dot array of, let's say, 0, 2, 8, 1, 14, and 7. Now my color is equal to red, green, purple, lime, and aqua, then yellow, plt dot scatter of xy color equals my color, and plt dot show. Let's try to run the cell. So we have obtained dots of scatter plots of different colors. So let's head back to the presentation slide. Now size, we can change the size of the dots with the S argument. Let's try to implement this program now. So we can import Matplotlib dot pyplot as plt, and we can import numpy as np, where x is equal to np dot array of 0, 1, 2, 3, 4, and 5. Y is equal to np dot array of 0 to 8, 1, 14, and 7. And now my color is equal to red, green, purple, and could be lime. This is aqua and yellow. Where size equals 10, 60, 120, 80, 20, and 190. And plt dot scatter of x, y, and the color is equal to my color of some size. This is plt dot show. Let's try to run this cell. So we have got this plot of different sizes. Let's head back to the slide. Now alpha, we can adjust the transparency of the dots with the alpha argument. So let's import the statement in the Jupyter. And for this, we have to import Matplotlib dot pyplot as plt. Also import numpy as np, where x is equal to np dot array of 0, 1, 2, 3, 4, and 5, and y is equal to np dot array of 0 to 8, 1, 14, and 7. Now my color is red, green, purple, lime, aqua, and yellow. Then the size is 10, 60, 120, 80, 20, and 190. Now plt dot scatter of x, y, the color is of my color, and the size where alpha is 0.3, and this is plt dot show. So let's try to run this slide and run this shell. Have to include and 190. Okay, so now we have obtained these values. Now let's head back to the presentation slide. So coming to bar graphs, these are convenient for comparing numerical values of several groups. Using dot bar method, we can create a bar graph. So this is a program to implement bar graph. Let's have a quick look at this program. Now from Matplotlib, import pyplot as plt, and then x is equal to 5, 2, 9, 4, and 7, and y is equal to 10, 5, 8, 4, and 2. Plt dot bar of x and y, plt dot show, Let's try to run the cell. So we have obtained a bar graph. Now let's try to create another bar. Import matplotlib dot pyplot as plt. Import numpy as np. And x is equal to np dot array a b c and d. Y is equal to np dot array of 3, 8, 1 and 10, and plt dot bar of x and y, then plt dot show. So let's run this. So we have obtained a bar chart and bar graph. So let's try to implement another program. Import matplotlib dot pyplot as plt, where x is equal to 1, 2, 3, 4 and 5, and y is equal to 6, 7, 8, 9 and 10. Plt dot bar of x and y, plt dot show. Let's try to run. So we have got a bar chart over here. So let's head back to the presentation slide. So with pyplot, we can use the bar function to draw graphs as we have seen here earlier. We have implemented this graph and we have implemented this graph too. So now let's try to implement this graph by importing matplotlib in Python. Now let's import matplotlib dot pyplot as plt, where x is equal to 1, 2, 3, 4 and 5, and y is equal to 6, 7, 8, 9 and 10. Z is equal to B, G, R, black, black and pink. Let's and plt dot bar of x, y and color is equal to Z. Plt dot show. So we have obtained bar graph of different colors here. So let's head back to the slide now. So these are the base colors: blue, green, red, cyan, magenta, and yellow, black and white. So these are a list of colors which we could import in the Matplotlib. Black, climb gray, clim gray and gray, clar gray, dark gray, silver, and the brown, fabric, maroon, dark red, and the dark orange, the forest green, lime green, dark green, green and lime, and all these colors, the violet, indigo, blue violet, and cyan. And now let's try to implement this Matplotlib bar plot and the Python notebook. So now let's import matplotlib dot pyplot as plt, where x takes the values of Python and it's C++, it is Java, and y is equal to 90, 65, 82, then it is 85. Plt dot bar of x and y, plt dot show. Let's run this cell. So we have got this value. Let's head back to the presentation slide. Matplotlib bar plots. So we have to import matplotlib dot pyplot as plt, and x and y z values are default. Then plt dot bar of xy with 0.4 and color of phi is align edge or center. Then edge color is R with line width 10 and line style. Color with alpha value 0.4. So import the we have to plot the bar graph with x set with 0.4 and color green, align edge and edge color red, line width 10, line style colon, and the alpha value 0.4. Label as popularity 1 for multiple bar graphs. And we have to plot legend show the X label with languages and font size, Y label with number and font size, and the title of graph with graph 1 with the font size of 10. And in order to apply the label, we must apply for legend. So we have to import the we have to import the multiple bar graphs overlapped in this manner. So let's try this program. Here we have to import matplotlib dot pyplot as plt, where x is plt dot bar of x, y, and width as 0.4. Color is white. Is aligned edge or center. And label this is the line width of 10. Alpha and the label this is for multiple bar graphs. Plt dot legend, plt dot show, and plt dot x label are the languages with font size 10. And plt dot title of graph 1. of font size is 10. So let's run this program now. Try to run this program now. So we have obtained this graph. Next, let's make a small change over here and let's try to import numpy as np, where x is declared as Python and C, C++, and Java. Y is declared as 80, 70, 60, and 82. Z is declared as 20, 30, 40, 50. Then P is equal to 0, 1, 2, and 3. Width is equal to 0.4. Let's try to run this shell. So we have obtained the popularity. Let's say P1 and let's try to run this cell. So it's over here and now we have to change the index of P, which is np dot arrange of len of x and here width is 0.4. Okay, and let's say P1, which is j plus width for j in P. So let's run. So here we have got this. This is an empty list. Align is H. Here H color is red and line width is 10, whereas line style is and then coming to alpha, it's 0.4 and even this is X and Y, X and Z, width is 0.4, align is H and then H color is red, line width is 10, line style alpha is equal to 0.4 and let's come back to the slide. Here with the 0.4 and np dot arrange len of x where p1 take j plus width for j in P. Here plt dot x6 p plus width of x. So next, let's try to implement p plus width divided by 2 and x with a rotation of, let's say, 10. Let's run this. Okay, so I have got this. So let's try to implement another program where import matplotlib dot pyplot as plt, and then my underscore data frame is equal to pd dot data frame and np random dot random values of 10 and 4. The columns equal to a, b, c, and d. My underscore data frame dot plot dot bar. Let's try to run this. So let's import pandas as pd and let's try to run now. So let's import numpy as np. From matplotlib, import pyplot as plt. So this is the graph. Now let's head back to the presentation. So we have done implementing all these bar graphs. Now we have to create a horizontal bar graph. If we want the bars to be displayed horizontally instead of vertically, we use the bar h function, and let's try to implement that. So we have to import matplotlib dot pyplot as plt, and we have to import numpy as np, where x is equal to np dot array of a, b, c, and d, y is equal to np dot array of 3, 8, 1, and 10, plt dot bar h of x and y, plt dot show. Let's run the program. So we have obtained a horizontal bar graph. So let's try to implement another program. Import matplotlib dot pyplot as plt, and then we have to import numpy as np, where x is equal to python, c, and c++, then it's java, where y is equal to 90, 65, 82, and 85. Z is equal to 23, 52, and 29, and 20. View width is around 0.8, and P is equal to np dot arrange len of x p1 is equal to j plus width for j in p, plt dot bar h of py width and color is of red, plt dot bar of p1z with color is of black, escape, then plt dot xsticks p plus width divided by 2 x and rotation is equal to 50. Plt.show, let's run this. So we have got the horizontal graph. So now let's try to find out the bar width. In order to do so, we have to import matplotlib dot pyplot as plt, and then import numpy as np, where x is equal to np dot array of a, b, c, d, and here y is equal to np dot array of 3, 8, 1, and 10. Here plt dot bar h of x, y, and width is equal to 0.1. Plt dot show from the cell. So we have got this. So let's head back to the presentation slide. So we have implemented this graph and this graph too. So the bar takes the keyword width to set the width of the bars. Let's try to implement this step plot. So for this, we have to import matplotlib dot pyplot as plt, plt dot step of x, y, and marker is O, whose color is R, ms is 10, and the MFC value is green. PLT dot legend, PLT dot grid, PLT dot show, PLT dot xlabel, languages of font size 10, PLT dot ylabel, number of font size is also 10, and plt.title graph 1 of font size is 10. So let's run this program. So we have got the step plot. So to align the bars on the right edge, we pass a negative width and align with edge. Now let's head back to the presentation slide. So moving on to histogram, it helps us to understand the distribution of a numeric value in a way that we cannot do it with mean, median, and mode. And a histogram is a graph showing frequency distributions. It is a graph showing the number of observations within each given interval. In Matplotlib, we use the hist function to create histograms, and the hist function will read the array and produce a histogram. So let's try to implement this. From Matplotlib, import pyplot as PLT, and y-axis values are 10, 5, 8, 4, and 2. plt.hist of y, plt.show. Let's run this. So we got a histogram. So let's try to import another histogram from import matplotlib.pyplot as plt, import numpy as np, x is equal to np dot random dot normal of 170, 10, and 250, plt dot list of x, plt dot show. Now let's run this cell. So we got this histogram. Let's try to implement another histogram. Import numpy as np, x is equal to np dot random dot rand n of 1000, plt dot list of x. Let's run this. So we have obtained a histogram. Let's head back to the presentation slide now. So we have implemented these programs, and now moving on to the time series line plot. It is a chart that shows a trend over a period of time, and it allows you to test various hypotheses under certain conditions, like what happens different days of the week or between different times of the day. So let's try to implement this program now. Here we have to import matplotlib dot pyplot as plt, then have to import date and time, and then import numpy as np. X is equal to np dot array of date and time dot date time of 2018 9/28 I 0 for I in range of 24, and y is equal to np dot random dot random of 100 size x dot shape plt dot plot of x and y plt dot show. So this is the time series plot. Let's head on to the presentation file now. So the functional approach in order to obtain the graph of this plot. And let's try to implement this program now. So this is a graph. Let's change the color to purple. So we have obtained the first plot graph in the purple color. So let's try to implement using the subplot. We'll create two plots on the same canvas. That is from Matplotlib. Import pyplot as plt, and then later import numpy as np, and where x is equal to np dot linspace of 0, 10, and 2, y is equal to x times 2, x raised to the power of 2, where plt dot subplot 1, 2, and 1. Next, plt dot plot x, y, and red. Then plt dot subplot 1, 2, and 2. Then plt dot plot y, x, and green. Plt dot show. Let's run this. So we have got this. Now let's get back to the slide. So we have implemented these graphs, and here the Matplotlib, it allows us easily to create multi-plots on the same figure using the dot subplot method. This dot subplot method takes in 3 parameters, namely enrows the number of rows the figure should have, and encalls the number of columns the figure should have, plot number, which refers to a specific plot in the figure. So using the dot subplot method, we have created 2 plots on the same canvas. Now, object-oriented interface. This is the best way to create plots, and the idea here is to create figure objects and call methods of it. Let's create a blank figure using the dot figure method. The figure is equal to plot dot figure. And the next step, now we need to add a set of axes, dot underscore axis, left, bottom, width, and height. So we have to do this manner. Let's try to implement these 2 steps. So initially, we've got a blank figure. Let's say from Matplotlib, import pyplot as plt, and then import numpy as np, and x is equal to np dot linspace of 0, 10, and 20. Y is equal to x raised to the power of 2. And then figure is equal to plt dot figure. Axis is equal to figure dot add underscore axis, that is of 0 0.1, 0 0.2, and 0 0.8 with 0 0.9, and axis dot plot of x and y. Let's try to run this. So this is an empty plot. Now if we add axis dot plot of x, y, and then purple, then plt dot show, we would get the output in this manner. The same case, and next axis dot set of x label, capital X label, x dot set underscore y label, it is y of label x dot set underscore title of first plot using object oriented approach. Let's run program now. So we have got this, and let's now try to create something interesting, that is figure in figure. We have got this. So this is a graph for figure in figure. And then now we can actually create a matrix for subplot of a subplot, for example, 3 by 3 matrix. So we can do that in this format. So as you see, this way we can do this. So let's head back to the slide now. So we can add plot dot tight underscore layout, but the only difference between plot dot figure and plot dot subplots is that plot dot subplots automatically does what the dot add underscore axis method of dot figure will do based off the number of rows and columns you specify. So we have implemented this. So let's try to implement figure size, aspect ratio, and DPI in figure. So this is how we do this. So this is how we do this. And in the case of subplots, let's try to do this. So in the case of subplots, we do in this way. And coming back to the presentation slide, so we have implemented figure size aspect ratio and DPI in figure in subplots as well. Now coming to legends. Legends, they allow us to distinguish between plots, and with legends, we can use label text in order to identify or differentiate one plot from another. For example, we have a figure having two plots like below. So let's try to implement. So there's the same figure as displayed earlier, where the red line stands for the cube and purple line stands for the square. And let's try to have a look at another program where we can actually differentiate. So here x stands this x square plot, it is labeled with the purple line, and the x cube plot is labeled with the red line. Now let's head back to the presentation slide. Now creating pie charts. So with pie plot, we can use the pie function to draw pie charts. How do we do that? Let's have a look. Let's upload a notebook. And let's name this as pie chart. Now we can import Matplotlib dot pie plot as plt, and then we can import numpy as np, where x is equal to np dot array of 35, 25, 25, and 15. Now we have to plot pi of y, then plot show. Let's run this. So we have got this. Let's head back to the presentation slide. And labels, in order to add labels to the pie chart, with the, we can do it with the label parameter. And the label parameter must be an array with one label for each wedge. So let's try to do this. Import matplotlib dot pie plot as plt. Then we have to import numpy as np. where x is equal to np dot array of 35, 25, 25, and 15. My labels is equal to apples, bananas, cherries, and dates. Plot dot pie of y labels is equal to my labels plot dot show. Let's try to run this. So we got this. Let's try to get back to the presentation file. Now start angle, as mentioned, the default start angle is at the x-axis, but we can change the start angle by specifying a start angle parameter. Now let's head back to the presentation file. Here we have to import matplotlib .pyplot as plt, and then we have to import numpy as np, where x is equal to np.array of 35, 25, 25, and then 15. Here my labels are apples, the bananas, and then the cherries, and then the dates, so I have to plot pie chart as plt.py. X labels is equal to my labels start angle is 90, plt.show. Let's run the cell. So we have obtained this value. Let's head back to the presentation file. Now explode. If we want one of the wedges to stand out, the explode parameter allows you to do that. Here explode parameter, if specified and not none, must be an array with one value for each wedge. So let's try to display the explode parameter onto the output screen. Here we have to import matplotlib dot pyplot as plt, and then we have to import numpy as np. X is equal to np dot array of 35, 25, 25 and 15. My labels are apples, bananas, cherries, and dates. Now my explode is 0, then this 0 and another 0 over here. So plt dot py of 5 labels is equal to my labels within start angle 90 and explode is equal to my explode. Plt dot show. Let's try to run this cell. So let's assign an explode value. We have got this. So let's display a shadow. We can add a shadow to the pie chart by setting the shadows parameter to true. And I can import matplotlib dot pie plot as plt and import numpy as np. X is equal to np dot array of 35, 25, and 25 and 15. My labels is equal to apples bananas cherries and dates, then my explode has a value 0.2200 and zeros, then plot dot by x labels equal my labels, and start angle is 90, then explode is equal to my explode, shadow value is true, this is plt dot show. Let's try to run this. So we have got this value. This is the shadow. Now let's head back to the presentation file. So we can add a shadow to the pie chart by setting shadows parameter to true. We have done this. And now we can set the color of each wedge with the colors parameter. So let's have a look at it. Let's use this colors parameter. And here colors equal to my colors. And before this, my colors are, let's say, black, and this is pink, and B, then it is let's print. So we got this, and so now let's try to implement the same program, the program. Let's head back to the presentation file. So we have done executing the colors using colors parameter. And now legend. In order to add a list of explanation for each wedge, we use the legend function. So let's try to implement this. plt.legend. So let's run this. So we got, and now let's try to implement legend with header. Now let's run this. So we have got the legend with header with the title of 4 fruits. Let's head back to the presentation slide. So to add a list of explanation for each veg, we use the legend function, have implemented this. And to add a header to the legend, we add the title parameter to the legend function, have implemented this too. And now let's try to implement these 2 pie charts as well. And in order to do this, we have to open a Python notebook. Now just we have to import Matplotlib dot pyplot as plt, where x value is 1, 2, 3, and 4. And here y value, it ranges from C, C++, and Java, then Python, plt.py of x, plt.show. Let's try to run. So we got this. So just let's modify the same program over here. Let's add plt of x and labels are y. Now let's run this. So we got the labels, and let's try to modify program. Here let's add z as a 0.40 and then 0 and then 0 and then let's explode the z. So now let's try to run the cell. So we have exploded z, and now let's add a variable as and the orange. Your colors are assigned to variable 1. So let's run this cell. So we got this. Initially, what we did is we have just exploded Z. Now here we have added variable 1 as extra format, and next now let's try to modify this format. R, C, and G, and that is of orange. We have assigned colors to variable 1, and auto PCT is percentage of 0.1 of the float value. Now let's try to run this cell. So we got this. Let's copy and paste. Now let's reduce this to, let's increase this to 0.3, and let's run this. So we got this, and let's try to add a shadow now. This is a shadow if it's true. Let's try to run this cell. So yes, and let's try to find a radius. Let's draw a circle with some a radius 1.5. So yes, and then let's add a label distance of 1.3. This is the label distance. Okay, then now let's try to insert the start angle of 90. All right, now let's add the text props of font size 15. Let's run this cell. So yes, this is radius of 1.5. Afferent initially, and then copy and then paste. This is the label distance. Of 1.3. And then start angle is 90. And text props, as we have seen earlier, it's font size of 15. Let's run. Okay, now let's try to modify this by introducing the counter clock. Counter clock is false. Let's try to run this. Okay, now let's try to copy the entire code. Your shadow is equal to true and text props is equal to the font size. Then wedge props line width edge color Let's run this. Let's try to copy the code now here and let's try to paste it. Your text pops. Line width of 5, and next let's try to run this. So we got this, and let's try to modify the same program as edge color. Edge color. Let's run this. So we have got this, and so let's try to implement the same program with some modifications of rotatables. Tables is true. So okay. Now first let's try to copy this cell. We have already implemented this earlier. The text props font size of 15. Okay. Now let's modify this rotate labels. So now let's add a title to this, like plot.title, list of computers and structures. Okay, and then let's add legend. Plt.legend at location 1. The location is equal to 1 to 10. Let's run this. Okay. So let's modify the program to radius 1.5 and plt.py of x1 as radius 1. Let's run this cell. Okay. Here we got this. Now let's modify this. plt.py of 1 where colors is equal to w. So let's run this. Okay. And now we have to import matplotlib dot pyplot as plt where x is equal to, then here y value, plt dot plot of x and y, plt dot save figure of say first name. This is DPI is 1000. The face color is G. Transparent value is true. And then plt dot save figure first name dot pdf plt dot show let's try to see the save figure. All right, let's try to modify this code as 1, 2, 3, 4, and 5. Then y value is say 90 and it is 65, 82, 85, and 80. Save figure of line. Now we have got this. And now let's try to work on the same concept and we have to modify the code. Here, let's take the values as 3, 2, 1, 3, and 4. Then plt dot xticks of x, plt dot yticks of y. Let's run the cell. So we have got this line. Now we shall modify the same program. Xticks of x labels. is equal to Python, and this is Java, C, C++, also HTML. Let's run this cell. So we got this, and let's try to modify the code again. We have plt dot x limits at 0 and 10, and to copy the same, plt dot access at 0, 10 and 0, 7. Let's run this cell. Okay. Let's head back to the presentation slide. So we have implemented all these pie charts so far. Implemented all these pie charts. And we have implemented this axis as well. So in text in Matplotlib is written text, annotate, X label, Y label, and title. Text text at an arbitrary location of the axis. Annotate it is used to add an annotation with an optional arrow at an arbitrary location of the axis, where X label adds a label to the axis along X axis and Y label adds a label to the axis along Y axis. The title is used to add a title to the axis. So text in Matplotlib is written in this, it is implemented in this way. So let's try to implement the program. Now plt dot text at 2, 3, then in Java, and then style is italic. Bbox is equal to, let's say, face color of C. Plt dot annotate Python xy text is equal to 4 arrow prop equal to dict of face color, that is green. plt.legend up at location 9. The face color is red and the edge color is C, and the frame alpha is 0.5, where the shadow is 2. From this, we have obtained the graph. So let's head back to the presentation slide. Now coming to visualization plots using Seaborn. So Seaborn, it is used for data visualization and it is built on the top of Matplotlib. Seaborn package and this Matplotlib package, it's matplotlib.pyplot of the module and pylab of the module. Here object level is APIs, Matplotlib APIs, and it is pandas package, numpy package with the pydate with and this whole is a pydata stack. And so its architecture, it is a figure is a top level container and pyplot APIs operate at higher levels and matplotlib APIs at lower levels. They operate at lower levels. And the figure, it is canvas and the axis. Axis is divided into minor tricks and major tricks. Now for installation, we have to install PIP install Seaborn. And then PIP install Seaborn, we have to upgrade. For testing, we have to import Seaborn as SNS_version. And it is used to disable warnings and to import warnings. We can use warnings.filter of filter warnings and ignore. And imports, we can import pandas as PD. In the same way, we can import Seaborn as SNS. We can import numpy as NP, and we can import matplotlib.pyplot as PLT. So to read data, we can do this by reading data is equal to pd.read_csv with CSV files, data.csv encoding in the script, and we have to print data.head of 100 to display the first 100 rows. And data.columns, these are the index of STN code, sampling date, state, location, agency type, SO2 number type, number 2, and RSPM, SPM, then location monitoring, station, and the PM2_5, the date and D type object. And so it's data cleaning is done by data of number 2, which is equal to data of number 2 dot fill NA of 0. This particular command cleans the data. And the distribution plot, DST is equal to SNS dot dist plot of data number 2, and the DST dot set underscore title, which gives us the pollution statistics of NO2 nitrogen dioxide, and set underscore of X label, which gives the air quality index of NO2, set underscore Y label, which gives the density of AQI. Then we have to show. So we got in this, we have got the Seaborn example in this manner. And now for vertical distribution, so this is the graph. But DST is equal to SNS dot dist plot of data number, data of NO2. I mean the color is green, the vertical is true. Then DST dot set underscore title is pollution statistics of NO2, and DST dot set underscore X label is air quality of index of NO2, and DST dot set underscore Y label is density of AQI. So we have the vertical distribution in this manner, pollution statistics of NO2. Now the mode variant is dst is equal to sns.distplot, and we have given the command over here. We have set the title of pollution statistics of NO2 and the air quality index of NO2, which is X label, and the Y label is density of NO2, and we have just plt.show. So now later we have this command of dst is equal to sns.distplot of data NO2, and the color is green. KDA is false, bins is 5. We have set the title pollution statistics of NO2, and we have to set the X label of air quality index of NO2. Then we have set the Y label as frequency, and the subplots and heat map. So this is subplots and heat map, and we have the plt.subplots of figure size 30 and 10. The COR data of data.cor, its correlation, and SNS.heatmap. We have the data of Vmax, square true, and the FMT value and the CMAP value. So this is the corresponding heat map. Now, to pair plot the value, we use the command called sns.pairplot the data, and we'll just show this. So sns.set, it sets default theme, and style is dark grid, palette is deep, and the font is sans serif. So sns.discipline, it is used to remove the lines. Now visualization of plots using the Seaborn. The visualization plot types are bar plot, strip plot, swarm plot, box and plot, density plot with filled area, histogram and rug plot, density plot with rug plot, histogram, density and rug plot, implot, reg plot, 2D KDE plot, joint plot, and pair plot. Now, bar plot using cat plot. So it is a Seaborn.cat plot of X none and Y none type. HU is none and data is of none type, and the kind is of bar. And so figure level interface for drawing categorical plots onto a spaced grid. And this function, it provides access to several level functions that show the relationship between a numerical and one or more categorical variables by using one of several visual representations. And the kind parameter in function cat plot, it selects the underlying functions to plot with the categorical scatter plots of kind strip for strip plot and kind swarm for swarm plot. And the categorical distribution plots, it is kind box for box plot and kind volume for volume plot and kind boxen for boxen plot. And the categorical estimate plots, kind point for point plot and kind bar for bar plot and kind count for count plot. And the parameters are x, y, h, u, e. Here name of variables in data and inputs for plotting long form of data stored. And the data, it is in the form of data frame, long form, and the tidy data set. The kind, it is string, optional, and the kind of plot to draw is bar, strip, swarm, box, violin, and boxen are stored in the kind format. Now the bar plot using the cat plot example, it displays the Titanic survival probability of class, and this, we have to see the Titanic survival probability of the class people. And on x-axis, a class is defined, and on y-axis, survival probability is defined, where blue represents female and brown represents male. So we have to draw a bar plot to show the survival of class and of male and female. Now this is a box plot and boxen plot using the cat plot. So this is a strip plot and swarm plot using the cat plot of kind strip, the kind swarm plot of total bill versus day, and strip plot of total bill versus day. We have box plot of total bill versus day, and boxen plot of total bill versus day. So coming to the histogram density plot, rug plot using this plot. So Seaborn.displot of A bins none and his true, KD true, rug false, and his underscore KWS is none, and KD underscore KWS and rug underscore KWS is none. And here it combines the Matplotlib hist function with the Seaborn KDE plot and the rug plot functions, and it is used to plot the same PDF over the data. Now we have got these parameters of A, bins, hist, KD, rug. A represents a series of one-dimension array or list. where bins represents the arguments of for matplotlib hist or none, it is optional, and it is specification for hist bins, where hist is a representation of boolean and it is optional whether to plot a non-histogram or not. KD represents the bool function of, and it is also optional. It is used to whether plot a Gaussian kernel density estimate. Rug is of Boolean and it is also optional. It is used whether to plot a rug plot on the support axis. And the hist of KD, rug, and fit underscore KWS, it represents the dictionaries. This is optional and it has got keyword arguments for underlying plotting functions. So this is the density plot using the dist plot. So this is an example of a density plot of NBA players' weight using Seaborn dist plot function. And have to load NBA data from file into pandas data frame. So this is the weight distribution of NBA players. And so this is a dist plot example. Here weight distribution of NBA players in the histogram. And SNS.distplot of A wins 15 KD false. And histogram KD and rug plot SNS.distplot of A rug true. This is KD and rug plot. And the third figure, it represents the histogram and the rug plot. With SNS.distplot of A bins 15 and KD false rug is true. The fourth figure represents KD and rug plot with SNS.distplot A bins 15 hist false and rug true. So coming to the implot, implot is Seaborn.implot of XY data, HU is none and call is none. And it plots data and regression model, fits across the facet grid, and it is used to combine reg plot and facet grid. So the parameters involved here are X and Y, and here the strings are optional. The data is from the data frame. It is tidy and of the long form, and the data frame with each column is a variable and each row is an observation. HV, call, and row, they are strings and the variables that define the subsets of the data. Now this is an example for the implot, the scatter plot with regression line showing sepal length and sepal width comparison of iris species. And so we have to draw the implot of iris sepal comparison and we have to save and show the figure. Here we have got an implot of sepal length versus sepal width. Sepal length is taken on x-axis and sepal width is taken on y-axis. So coming to reg plot, so it has got Seaborn dot reg plot of x and y, where data is none, x underscore estimator is none, and x underscore bins is none, and fit underscore regression value is true. It is used to plot a data and a linear regression model fit. Parameters involved here are x and y, where they represent strings, series, or vector array and the input variables. And the data has got the data frame structure, which is tidy and of long form. And the data frame where each column is a variable and here each row is an observation. And the x underscore estimator is called that map vector, which is a scalar and optional. And x underscore bins is an integer or vector value. This is also an optional. And fit underscore regression is of Boolean data type, which is optional. And if it is true, we have to estimate and plot a regression model relating the x and y variables. Now this is a reg plot example. It displays reg plot of total bill versus tips using tips data set. First of all, we have to plot 2D kernel density plot and we have to plot scatter plot and also fit a regression line. Then we have to save and show the figure. So here, reg plot of total bill versus tip. Total bill is plotted on x-axis and tip is plotted on y-axis. Now coming to 2D density plot using KD plot. So Seaborn.KD plot of data to none, and shade value is false, vertical is false, and kernel is GAU. We have to fit and plot a univariate or bivariate kernel density estimate. So for this, the parameters are data like 1D array-like structure, where we have to input the data. And data 2 is 1D array-like structure. This is optional and it is a second input data. If it is present, a bivariate KD will be estimated. The shade is of wool and it is also optional. And if it is true, shade is in the area under the KD curve, and the vertical, it is of Boolean data type. This is also optional. If it is true, then the density is on x-axis. And the kernel, kernel, it has got GAU, COS, PIW, EPA, try and try W. These are all optional. And this have got, the kernel has got code for shape of the kernel to fit with, and it has bivariate KDE. This can only be used with Gaussian kernel. Now this is an example for 2D KDE plot of total bill and tip from tips using the data set. From the data set using the Seaborn KDE plot function. So we have sns.set style white of palette dark and the color score is true. We have to load tips data from file into pandas data frame. Then we have to plot 2D kernel density plot. And if the C bar is true, we have to draw a bivariate KDE plot and we have to add a color bar. Then if shade is true, then shade is in the area under the KDE curve. This is a 2D density plot of total bill and tip. Total bill is plotted on x-axis versus tip plotted on y-axis. And joint plot, it is a joint plot is a Seaborn dot joint plot of x and y. Data type is none. The syntax is kind and scatter. And stat underscore function is also none. It has got no color. So now we have to draw a plot of two variables with bivariate and univariate graphs. So the parameters here are x and y, which are strings or vectors, and data are names of variables in data. The data is of data frame. This is optional, and the data frame, it takes x and y are variable names. And the kinds of scatter, regression, recite, KDE, and hex, these are all optional. And the kind of plot to draw, the stat underscore function is callable or none. This is also optional and deprecated. And the color is Matplotlib color, which is optional. The example of joint plot is we have to show a rect plot with a univariate plot on each axis using the joint plot using the tips data set. And we have to rect plot with a univariate plot on each axis using the joint plot. And then we have to add a title, set font size, and move the text above the total axis. This is a joint plot of total bill and tip. Total bill is, it's plotted on x-axis versus tip on y-axis. Now coming to the final plot, that is pair plot. So the pair plot, the syntax is Seaborn.pair plot of data, where it has got the HU value as none and HU underscore order as none. Palette is none and the VARS value is also none. The variables, and we have to draw a plot of two variables with bivariate and univariate graphs. The parameters are data, the data frame, and which is tidy of long form data frame, where each column is a variable and each row is an observation. HUE is of a string of variable name. This is optional. And variable in data to map plot aspects to different colors. HUE underscore order is the list of strings. It has got order for the levels of the HUE variable in the palette. And palette is or Seaborn color palette. It has got some set of colors for mapping the HUE variable. If a dict key should be values in the HUE variable. And variables is a list of variable names, which is kind of optional. And the variables within data to use. Otherwise, we have to use every column within a numeric data type. Now, the example of pair plot is here, which displays a pair plot using the iris data set. So, syntax is sns.set of color underscore codes is true. So, this is a pair plot graph of iris species comparison. We have to load tips data from file into pandas data frame, and then we have to load the data of color names. And then iris we can load from the CSV file dot iris CSV. Iris CSV. So the data is iris. HUE species. So the iris data plot. We have to plot the pairwise plot. Like if the data is in the form of iris and HUE is in species, so we have to pair plot the super title as iris species comparison. And the font size is 12. The font weight is semi bold. So we have to pair underscore plot and we have to save the figure pair plot underscore iris dot PDF, and we have to plot the data by using plot dot show, which displays the iris data onto the output screen. Now coming to the summary part. We have the plot types called categorical data of visualization: bar plot, strip plot, swarm plot, con plot, box plot, boxen plot, and violin plot. And these all have got the API call of Seaborn.cat plot. X is none, Y is none, H is also none, data is none, and kinds of bar graph. And the distribution of data, it has got plot types of histogram, density plot, rug plot. These have got the API call of Seaborn.bisplot. A bins none, hist is true, KD is true, and rug is false. And hist underscore KWS is none, KD underscore KWS, and the rug underscore KWS is also none. Now coming to density part, it has got the API call as Seaborn.kd plot of data. Data 2 is none, shade is false, and vertical is also false. Kernel is GAU, and pair plot, it has got the API called Seaborn.pair plot of data. HU is none, HU underscore order is also none, palette is none, and variables is also none. Join plot, it has got the API call as Seaborn.join plot of X and Y. Data is none, and kind is scatter. Stat underscore function is also none, and the color is none. The linear relationship, it is a scatter plot with regression line. It has got this API calls as Seaborn.rect plot of X and Y. Data is none. X underscore estimator is none. X underscore bins is none, and fit underscore regression is true. Seaborn.implot, it has got the API call as X and Y data. HU is none, and the columns are also none. So what have we learned so far, and why? I've learned the data visualization. Oh, how we can integrate the visualization technique in machine learning model, and we can sell the visualization to company by the data, and how to plot Seaborn and not plot, and how both of them are replacement to each other, and how they differ from each other, and how in what ways are they similar to each other. We have learned all this. So, so thank you. That's the end of the presentation.